So here the next part of the unit is, that is structure of atom. In the structure of atom, let us go to, that is introduction. In the introduction, we know that atoms and molecules are building blocks of matter, and if you go to, particularly if you are going to the atom, if you go to the atom and if you speak about its composition, it contains, when you are saying composition of atom, mainly it is made up of electrons, protons, and neutrons. It is made up of electrons, protons and neutrons, in which that is protons and neutrons in general, they are together called as nucleons, and these protons and neutrons together, they are present in nucleus of atom. And you know very well that electrons are present outside the nucleus. Outside the nucleus. If you take the nucleus, you go into the nucleus, outside the nucleus. So suppose if you go to the rational, the structure of the atom, a simple empirical structure of the atom, if you take, here you can take the positively charged nucleus. This is positively charged nucleus, and it is made up of two fundamental particles. In fact, when you say atom and its composition, you can say this composition of the atom is made up of fundamental particles. There are more than 100 fundamental particles are present in atom actually, but among so many different fundamental particles, we take only 3 fundamental particles, that is electrons, protons and neutrons, as a main preference of our discussion. So inside the nucleus of an atom, we have 2 fundamental particles, that is protons and neutrons, and outside the nucleus, if you take outside the nucleus, that is, suppose for example, because you know very well that the atom is anyhow spherical in shape, so for example, rationally I am going to draw a few orbits, the circular paths I am going to draw, but not many. This is the first circular orbit, then second circular orbit, then likewise third circular orbit, fourth, and so on. So what you are noticing here is, because atom is spherical in shape, so outside the nucleus we have, these are circular orbits. Here we have electrons. In all the cases you find electrons, and these are circular orbits which are circular, and this is nucleus. Protons and neutrons together, they are called as nucleons, and this is interorbital space, and that means what we are able to understand is, from this it is very clear that it has 3 fundamental particles, 1 proton, 1 neutron. Electrons are present outside the positively charged nucleus, and these orbits, they are circular. They are showing the circular paths, and here you find the outside the nucleus, you find certain amount of electron density. This is the electron density outside the nucleus. All these dots, you can see that more the number of electrons, more is the electron density. Either you can call it as electron cloud, or you can call it as electron density. So this is electron E bar means electron density, or you can call it as electron cloud. And from this diagram it is very clear that this is the structure of the atom. This is structure of atom, because atom itself is very small in size. The atom itself is very small in size. The size of atom is 1 angstrom, which is equal to 1 angstrom, and it is equal to 10 to the power of minus 8 centimeter. And the nucleus is much more smaller. So the size of nucleus, if you take, it is equal to, that is 10 to the power of 1 Fermi, we say 1 F. The size is 1 Fermi. 1 Fermi is equal to 10 to the power of minus 13 centimeter. So actually here 1 Fermi is equal to 10 to the power of minus 13 centimeter, or 10 to the power of minus 15 meters. 1 Fermi. 1 angstrom is equal to 10 to the power of minus 8 centimeter, which is equal to 10 to the power of minus 10 meter. Sometimes 0.1 nanometer also you can take, nanometer. So these are all important conversions, and it is very clear that the size of the atom is greater than the size of the nucleus. So size of atom is greater than the size of nucleus. From the values we can say that the size of the atom is greater than size of the nucleus. So the next part of the discussion is, that is important properties of, important properties of fundamental particles of atom. Important properties of fundamental particles of atom. So now what is happening here is, you know that the fundamental particles of atom, if you take, here we have three fundamental particles. A, one is electron, B, proton, and C, that is neutron. So first of all, let me take the first case, that is, if you take the first case, that is A, first one, if you take properties of electron, if you go to the important properties of electron, it was discovered by J.J. Thomson during discharge tube experiments. First point. Second point, then if you go for this electron, what are actually these electrons? These electrons are actually called as stream of negatively charged particles. Stream of negatively charged particles. Okay, that is called beta particles. Stream of negatively charged particles called beta particles. And if you take the mass of electron, its mass of electron is actually equal to 1 by 1837 times that of mass of proton. Mass of electron is equal to 1 by 1837 times that of the mass of proton, or in other words, you can take mass of electron, M stands for mass of electron is equal to 1 by 1837 times that of the mass of proton, or mass of proton is equal to, mass of proton is equal to 1837 times that of the mass of electron. So from this it's very clear that the mass of proton is greater than mass of electron. Then if you go for the charge continuation, You go to the charge, next continuation, next part of the discussion. Electron is continued. If you go to the charge of electron, normally if you take the charge of electron, it is negatively charged particles, but if you take the absolute charge that is equal to, that is minus 1.602 into 10 to the power of minus 19 coulombs, because the charge of electron, the charge of any particle is expressed in coulombs. So minus 1.602 into 10 to the power of minus 19 coulombs. Similarly, if you go for mass of electron expressed in AMU, that is, if it is absolute mass of electron, if you take, this is 0.00055 atomic mass units. Also you can take. Then if you want, you can add few more points. Specific charge of electron. Specific charge of electron is equal to, that is nothing but E by M. E by M of electron. E is the electronic charge of electron, M is the mass of electron, which is equal to 1.76 into 10 to the power of 8 coulombs per kg is the specific charge of electron. So all these are the properties of, electrons. All this comes under the properties of electron. Now similarly, let us go to the properties of the protons.